energy. This is part 2 in our video. And what is thermal energy? Well, we talked about it in the last video. It is heat. It is the flow. Here's the key word, the flow of heat. So we'll talk about thermal energy and the flow of heat. We'll talk more about that. Also in the last video, we talked about what would happen if the sun miraculously disappeared. We'll talk about that. What would happen to the Earth? And we'll talk about that later in the video. So thermal energy, the flow, make sure you know that, the flow of heat is radiation. And there's many types of radiation. Sure, you may have seen this symbol up here, right? The radiation symbol. This is when radiation is dangerous. You don't go in that area. Radiation is dangerous. So there are many types of radiation. We'll talk about more about radiation in other videos. But there's X-rays, for example. X-rays is a type of radiation. And if you go to the dentist's office, he'll check your teeth, right? He'll have to take X-rays. And he puts that lead blanket on top of you because X-rays can be dangerous. But the lead protects you. And also there are, many types. We'll talk about gamma rays, right? If you know the Hulk, he had gamma ray. Gamma radiation is very dangerous. And we'll talk more about that. And of course, there's sunlight. Sunlight is radiation, right? Those UV rays, those UV ultraviolet rays that give you your tan, right? And vitamin D. The UVB rays give us our vitamin D. All these are radiation. And visible light is radiation. The sun's light is radiation. A candle gives off radiation. So some radiation is bad for you, and some radiation will not harm you. So when we're lighting a candle, and don't do this at home, but we have a candle, not a candle, but some matches. So here we have, of course, thermal energy. So we have the sulfur and the red phosphorus in this match, creating this chemical energy. And of course, if we kept it there, it would just burn down and it would be not too good. But you can feel a little bit of the heat. So that's the heat being transferred. That's thermal energy. And again, don't do that at home. So again, your cell phone gives off radiation, right? Your cell phone. And of course, the microwave. And many others we'll talk about in other videos when we talked about radiation. But the radiation we're going to be talking about now is thermal radiation. Just the radiation that we get for, let's say, for example, on your stove. Right, and so we have the radiation from the stove, right? That's the heat source, and it's going to heat up the water in your pot, and we'll talk about these other terms, convection and conduction. We'll talk about those other terms. All right, so here is our stove, and we see the radiation, and it's very hot. You don't want to put your hand on the stove, obviously, so that's the radiation coming from the stove. It's our heat source. And so we take a pot of water, and we know that the heat, the radiation, is going to boil the water, right? So it's going to move the atoms in the water, and that's convection. Convection is the movement of heat, it's a transfer of heat from our radiation into the water. It's going to create that boiling water, and that's our convection. So we'll wait for that to boil. All right, so you can see the steam, it's getting hotter, right, the water. So we have our radiation source. The radiation from the stove is heating the water, and that is convection because the water, the atoms and the molecules are moving very quickly. They're circulating, and that's convection. And you can see the evaporation now with the steam as the water turns into a gas. The heat from the water is heating the pot. So you would not want to touch your hand with this pot because that's conduction right there. And the spoon is getting hot, but the material on the handle of the spoon, the manufacturers of the spoons, they do put a material that will insulate some of the heat, so you can leave your finger there and you won't burn your finger. But the heat is moving from the spoon that's in the water, slowly moving up the handle. So if we took out the handle and touched the little part of the handle near the spoon, that'll be very hot. So that is conduction. It is moving heat from one source, one substance to the other source. All right, so again, here's this crude picture of the stove. So again, the radiation is the heat. The heat is coming off the stove. Here is our spoon, right? So when we took the spoon, we take the spoon out of the pot. Right here, this part is very hot, That's conduction, right? The heat from the water went onto the spoon. And on the handle, because there's some insulation in here, they call it an insulator, it takes a lot longer for the heat to travel up, and so it would make your thumb hot. All right, so they could put plastic or different alloys in the spoon to make as an insulator. So the word insulator are poor conductors. Metal is a great conductor. That means the heat will transfer quickly. But poor conductors would be like wood and plastic. Right? So again, with conduction, just remember, like let's say you had this mug, right? New York Mets. So in this mug, when it gets hot, right, you can see your hand. If you put your hand on the mug right here, you put your hand on it, the heat from the mug will transfer to your hand. That's conduction. It'll get very hot. So you want to use the handle that has more different alloys in it that will insulate, called insulators, and they'll protect your hand. So that's insulators and conductors. So again, just reviewing. Here's our pot. Right, and we have the evaporation, right? So we have the radiation on the bottom. We have convection, right, where the atoms are circulating very quickly, causing the water to get hot and boil. Evaporation, say that 2 times, evaporation. Evaporation, where the liquid turns into a gas or a vapor. And here we have our handle, right? And if it was a wooden handle, it would take less time for the heat to travel. It's a good insulator, the heat of a wooden handle. As you move down closer to the pot, though, it'll get hotter as you move closer to the pot. And if you put your hand on the pot, of course, you can see that it would hurt. It would get very hot and you can burn yourself. So be careful with that. All right, so now let's look at what we talked about in the last video. We talked about the sun's energy. What would happen if the sun disappeared? We talked about that in the last video. So let's go over what would happen. So here's the sun. Let's make this big green thing the sun, right? And so here's the Earth, and of course light travels 186,000 miles per second, which we went over in the last video. And so we wouldn't know that the sun just disappeared for at least 8 minutes, or a little over 8 minutes. And if it was nighttime, of course we would know, right? If you were going about your business at night, whatever you're doing, going to the movies or something, you probably wouldn't know. Of course, if it was a full moon, the moon would disappear, right? Because the moon reflects light. But in about 8 minutes, a little over 8 minutes, when here's Earth's orbit, all of a sudden, the gravitational pull of the sun would stop. Let's look this up so we can see more of Earth's orbit. So, okay, there we have the sun pulsating. Let's get that a little focused. So when the gravitational pull of the sun stops, the Earth will just continue in a straight orbit out into space. Just a straight orbit out into space, going pretty fast too, going over 60,000 miles per hour. Of course, nowhere near the speed of light. So, the first thing we would notice after 8.5 minutes, besides the Earth going in a straight line into outer space, is it will turn, guess what? Dark. It'll be completely dark. We will still see the stars, but we will see no moon, and of course it'll be dark. Now we have artificial light, so we can continue with that. The next thing that would happen, of course, is because since there is no sun, there'll be no photosynthesis, right? And if there's no photosynthesis, and we'll go over photosynthesis, we'll do videos on that, how the plants eat, right? Plants need to eat with this, and the plants would die. So within a couple of days, the plants will die. Within a week, they'll probably be all dead, except for the trees. The trees will survive. Also, in 1 week, the temperature will drop. It'll get to about 32 degrees Fahrenheit, which is about winter temperatures for us. But within about 1 month, we'll just put a 1 month, the temperature will drop even more. So 1 to 2 months, it'll drop to negative 190 degrees Fahrenheit. Everything, all the animals that are outside will die. That's an extremely cold temperature, 190 degrees Fahrenheit. We don't get that on Earth now. And it will continue to plummet. It will continue to go down. So the plants are dead, and the animals that rely on the plants will be dead. And of course, after a month or 2 months at 190 degrees Fahrenheit, all the animals are dead unless we save them. And even we will have a problem with our food supply. We will have a definite problem with our food supply within 1 or 2 months. Now, within a year or less, the oceans will freeze. The surface of the oceans will freeze, but the inside the oceans, they will not freeze. All right, so this is what Earth would look like. Let's bring that up a little. So here's Earth now, right? And the big blue, right? And of course, in about 2 or 3 years, or maybe less, it'll just be a solid planet of ice, right? But that's on the surface, though, because the inside, because of geothermal energy, the oceans deep down would still be warm. In actuality, all those microorganisms that live on the bottom of the ocean floor, those strange creatures, they'll survive because of those thermal vents. And there is also volcanic activity on Earth that may last for a while, that may give us some heat. But within 3 years of the sun disappearing, it'll be very hard for humanity to survive. We will survive. Very few of us will survive. There'll be an elite few that will survive, probably in caves or in submarines or something like that. If we had enough time, we probably could survive. But if it happened very quickly, no, we probably would not survive. Much of humanity will disappear. So we rely on the sun. We need the sun. It is very important for life on Earth. And this geothermal energy will last for a long time, but within 1,000 years, Earth's atmosphere will completely collapse, so then all the oxygen will just leave. So for a long time, we will still have oxygen on Earth. We will still have geothermal energy. All right. So now we're talking about Earth's system, the systems on Earth. We talked about the sun and thermal energy. Now let's talk about what's happening, how we rely on the sun and Earth's systems in the next video. Great job.